Here we have a right triangle with a hypotenuse here, which is opposite the 90 degrees, and an angle theta. We have an adjacent side. Let's let ADJ represent the length of the adjacent side, and HYP represent the length of the hypotenuse. The cosine is a function of theta. We usually write it without the parentheses, cosine of theta. It equals the ratio of the adjacent side to the hypotenuse. The cosine function has a partner called the secant of theta, written SEC theta. It equals 1 over the cosine of theta, which equals then the hypotenuse divided by the adjacent. Notice that 1 over the cosine of theta equals 1 over this, the adjacent over the hypotenuse. If we multiply the numerator and denominator by the hypotenuse, then the answer is hypotenuse over the adjacent, which is the secant of theta. Let's look at this right triangle. We see here's theta. This is the adjacent side. It's right next to theta. And here is the hypotenuse, whose length is 5, which is opposite the right angle. So the cosine of theta, which equals the measurement of the adjacent side over the hypotenuse. Now we have numeric values, 3/5. So the cosine of theta is 3/5. Now let's consider this triangle. We're given the hypotenuse with a length of 8, and we're given that the cosine of theta is 1/4, but what we want to do is find the length of the adjacent side. We know that the cosine of theta equals the adjacent over the hypotenuse. So for here, we know that the cosine of theta is 1/4, and then we're looking for the adjacent, and the hypotenuse is 8. If we multiply this equation through by 8, we have 2 equals the adjacent side. So now we know the adjacent side measures 2. So notice, given that the cosine of theta equals the adjacent divided by the hypotenuse, if we multiply this equation through by the hypotenuse, we can find the answer for the adjacent side. We see that the adjacent side is going to be the measurement of the hypotenuse times the cosine of theta. And this works every time.